Hello, we are the Group Optimists, and we are discussing number systems arithmetic, addition and subtraction. Let's get started. In this part, I will teach you how to add and subtract decimal number system. But first, I will give you a short information of decimal number system. Decimal is a numbering system that uses a base 10 representation for numeric values. The system is used extensively in everyday life to carry out routine tasks such as buying groceries, trading stocks, tracking football scores, or scrolling through cable channels. Numbers such as 7, 28, 199, and 532.11 are all examples of decimal numbers. The decimal system is also referred to as the Hindu-Arabic system. Additionally, the term decimal is often used to refer to a fraction that is represented as a number in the decimal system, such as 19.368. Adding and subtracting decimals is pretty easy, because we probably learned this in our elementary days. It is also we almost use in our daily life. First example is addition. 663 sub 10 plus 84 sub 10. Three plus 4 is 7. 6 plus 8 is 14, so we carry 1 to the next number and put 4 below. Then 1 plus 6 is 7. Now we have the answer 747. Second example is 578 sub 10 plus 285 sub 10. Eight plus 5 is 13, so we carry 1. 1 plus 7 plus 8 is 16, so we carry again. And 1 plus 5 plus 2 is 8, so we have the answer 863. So that's all for addition. We will do subtraction now. First example for subtraction is 853 sub 10 minus 289 sub 10. We can't do 3 minus 9, so we will borrow next to 3, which is 5. The number we borrowed from will become 4, and 3 will become 13, because we borrow on the next number place, which represents as 10. So 13 minus 9 is 4. We can't also subtract 4 to 8, so we have to borrow again, like we did last time. Fourteen minus 8 is 6. 7 minus 2 is 5, and now we have the answer 564. Here, in our last example, we will have 850 sub 10 minus 376 sub 10. We can't do 0 minus 6, so we will borrow just like what we used to do. Now, 10 minus 6 is 4. We can't also subtract 4 to 7, so we borrow again. Fourteen minus 7 is 7. 7 minus 3 is 4, and now we have the answer 474. That's all for addition and subtraction of decimal number system. Thank you. Next we will be discussing binary addition and subtraction. Let's us define first what is binary addition. Binary addition refers to the process of adding two binary numbers together, similar to decimal addition. It involves carrying over the 2's digit to the next column if the sum of two numbers is greater than 1. Let's move to binary addition rule. According to this rule, 0 plus 0 is equal to 0. Next is 0 plus 1 is equal to 1, and 1 plus 0 is also equal to 1. While 1 plus 1 is equal to 0, carry 1 to the next column. Because in decimal system, 1 plus 1 is equal to 2, and the binary of 2 is 10. Similarly, if you add 1 plus 1 plus 1 in previous column is equals to 1, carry 1 in previous column. Because in decimal, 1 plus 1 plus 1 is equals to 3, and in binary code, 3 is equivalent of 11. For example, in binary addition, let's add 0, 1, 1, 1, plus 0, 1, 0, 1. So let's start. 0 plus 0 is equals to 0. 1 plus 1 is equals to 0. Carry 1 to the next column. 1 plus 1 is equals to 0. Carry 1 to the next column. Next, 1 plus 1 is equals to 1. Carry 1 to the next column. Lastly, bring down 1 and the answer will be 0, 0, 0, 1, 1. Let's check if our computation is correct. We need to convert our binary numbers into decimal numbers. By getting this number, we need to use bits to convert our binary numbers to decimal numbers. Let's add the first binary number. 8 plus 4 plus 2 plus 0 is equal to 14. The decimal number for 0, 111, is 14. Next, let's add the second binary number. 8 plus 0 plus 2 plus 0 is equal to 10. The decimal number for 0, 101, is 10. Let's add the first and second decimal numbers. 14 plus 10 is equals to 24. 16 plus 8 is equals to 24. That means our computation is correct. Let's try this. 0, 1, 1, 0, 1 plus 1, 1, 1, 0, 1. The answer is 1, 0, 1, 1, 0, 1. Let's move to the next topic. What is binary subtraction? Binary subtraction is one of the 4 binary operations where we perform the subtraction method for two binary numbers, comprising only 2 digits, 0 and 1. This operation is similar to the basic arithmetic subtraction performed on decimal numbers in maths. Let's move on to binary subtraction rules. 0 minus 0 is equal to 0, while 1 minus 0 is equal to 1. Next, 1 minus 0 is equal to 0. Lastly, 0 minus 1 is equal to 1, with barrow 1 to the next column, because 0 is lesser to 1, so we cannot subtract. Let's start our computation. Here it is 0 minus 1, since 0 is lesser than 1, so we need to borrow from the next column. For example, in decimal number system subtraction, whenever we are borrowing from next column, we reduce the digit by 1 and carry this one to the right column as a value of 10, and we will do the subtraction. It is because in case of decimal number system, the place value of each digit increases by 10 times. But in case of binary number system, the place value of each digit increases by 2 times. This is a very important point to remember while doing binary calculations. Let's get back to our binary subtraction here. To understand easily, we will refer each column by its weight. Now we have to borrow from 2 columns to 1 column. The weight of 1 inch 2 column is 2. So whenever we put this one in 1 column, we must represent it as 2 times 1. Or we can say that there are 2 ones in 1 column. So after subtracting 1 1 from 2 ones, we will get 1 inch the answer. This is what I have mentioned in last rule of binary subtraction. 0 minus 1 equals to 1, whenever 1 is borrowed from next column. Now we will move to the next column. In 2 column we have 0, because 1 is already borrowed to 1 column. So here it is 0 minus 1. So once again, we need to borrow from next column. Since 0 is lesser than 1 in the next column, the weight of the 1 is equal to 4. So first, this 1 will be replaced by 0, and whenever this 4 goes into 2 column, it becomes 2 times 2. So now if we perform the subtraction, then we are actually subtracting 2 2's minus 1 2. That is equals to 1 2. So we write 1 as the answer in 2 column. Hence, whenever we are borrowing from next column, we will write it as 2 in that particular column. Because in binary number system, each digit's place value increases by 2 times. We must always remember this phenomena while doing binary subtraction. So now let's move to the next column, that is 4th column. Here we have 0 dash 0. That is equals to 0. Now we will move to the 8th column. Here it is 1 minus 1 that equals to 0. So after the subtraction, we will get 0 0 1 1 as the result. So now let us convert this binary numbers into decimal numbers to check the answer here. The equivalent of 0, 1, 1, 1 into decimal number is 14, and the equivalent of 1, 1, 0, 1 is 11. 14 minus 11 is equals to 3. So our answer is correct. Good job, I hope you learned something. Moving on to octal addition and subtraction, let's discuss octal addition first. As mentioned in the last lesson, octal is base 8, which means that any value that is greater than 7 isn't acceptable. So for example, 4 plus 5 is equals 9, the sum isn't acceptable, so you have to break it down like this. 1 times 8 plus any value that would make the answer 9, so we will put 1. So your new sum for 4 plus 5 would be 1. Now let's include the carry rule. Let's solve 44 plus 15. Repeating the same rule as mentioned earlier, the sum of our 4 plus 5 would be 1. But what about the 9? You carry it over to 4 plus 1. Its value wouldn't be 9, but 1. Why is that? Because a carry is always valued as 1. That's simple. Now 1 plus 4 plus 1 is equals 6. The value is less than 7, so no need to carry. So our final answer for 44 plus 15 is going to be 61. Let's do another example, 55 plus 55. Let us solve each one in detail. 5 plus 5 would be 10, and that is greater than 7. So let's break it down. 1 times 8 plus any value that would make the answer 10. So we will put 2. Our new sum is 2. So let's carry the 10, which will be automatically be valued as 1. Now let's do the next one, which is another 5 plus 5, including the carry one. Replicating the same rules and process as earlier, the answer would be 3. This time we had a second carry that doesn't have any value to add to, so we will simply bring it down. So our answer for 55 plus 55 in octal addition is 132. Let's move on to octal subtraction. Octal subtraction is much more simple. Let's say the given problem is 13 minus 4. 3 is higher than 4, so we will borrow from 1. After borrowing, we can do the following equation. Base 8 plus 3 is 11, we minus 11 to 4, and that would be 6. So our answer for 3 minus 4 is 6. The borrowed 1 is going to be 0. So the final answer for 13 minus 4 is 6. For clarification, let's say the problem is 14 minus 3. You don't have to borrow from 1 because 4 is higher than 3, so you will only do basic subtraction. Therefore, the answer for this problem is going to be 11. That is all for octal subtraction. Let us now proceed to hexadecimal addition. Remembering the rules for additions, let's take a look at the examples. Pay close attention, because we'll make an exercise for you all listeners. Let us now proceed to hexadecimal addition. Remembering the rules for additions, let's take a look at the examples. Pay close attention, because we'll make an exercise for you all listeners. B plus D. B is 11, D is 14. (14 plus 11 is equals to 25. Now, according to the rule, if the outcome is larger than 16, we must subtract it, based it to 16. (25 minus 16 is equal to 9. Carry 1 to next column then. C plus 1 plus 5 is what? Remember to always convert letters into numbers. Pay a close attention to the procedures and try to comprehend the next step. Remember to always analyze the rules stated before the start of this demonstration. Using the same logic, we would use it from rightmost to leftmost. So that'll be C plus 1 plus 5. 18 minus 16, the answer would be 2. Since the answer is almost always larger than 16, we would carry 1 to the next column. Simply add 2 plus 1 and 4, we'll get 7. You may use your own solution or free calculator in the internet. We'll take another example since this is too easy for us. Now that we are familiar with the hexadecimal addition, we'll now proceed to subtraction. I find this easier to understand than hexadecimal addition. But what would be the rules when it comes to hexadecimal subtraction? Same as addition, start from rightmost to leftmost. If the number is resulted into cannot be, then borrow 1 to the next column. If the number is lower than 16, we may borrow 16 since hexadecimal is based to 16. Then proceed to deducting from the subtrahend. Since 9 minus d is cannot be, we'll borrow from another column. A is 10, and that'll be 9. Now 9 from the rightmost column will be cancelled. That'll be 9 plus 16 is equals to 25. Now 25 minus d, which is 13, is equals to 12. And 12 in hexadecimal is equivalent to letter C. See? Pretty easy. What about the next column, 9 minus b? But 9 minus b is cannot be, since subtrahend is larger than the minuend. Now we'll borrow again from the next column. E will be d minus to f. Again, 9 plus 16 is 25. Same rule from the last column. So 25 minus b is equals to 25 minus 11 equals to 14, equivalent to letter E. Now put it into the difference. You can still follow, yes? Let us proceed to the next column, which is d minus f. Again, d is cannot be, since f is larger than the minuend. We will borrow again from the last column, which is the leftmost. D is cancelled, turning into 13 plus 16 equals 29. Now 29 is acceptable to subtracting letter f. That'll be 29 minus f is equals to 29 minus 15. So it'll be 14. 14 is letter E, based to 16. Still get it? Let's put E to the third column, then we will now proceed to the last part. So that's C minus 4. C minus 4 is equals to 12 minus 4, equals to 8. That's the final value. DEA, 9 minus 4 FBD based to 16 is equals to 8 EEC based to 16. That's the end of our discussion. Hope you all enjoy. Stay safe and God bless.